All right. So if you want to keep earning points this way, get some good experience, keep doing this. If at any point you want to start building these on your own, have at it. If you want to start working on another one because you're sick of baseball, definitely you can do that as well. But let's look at another one here. So let's look at test best. Um, Best cost per win all time, best cost per win total all time. So this is the best cost per win total all time function right here, and it's returning a map of year and the team that had the best cost per win total, and then the flip side of that is the worst. So the interesting thing is once I've done one, I can also figure out the other at the same time. Um, that's looping through here. So I can actually, um, you know, I can actually cheat a little bit and have a helper method or something to not have to do this logic twice. But if you did the logic twice, it's not the worst. Um, Here I'm actually creating some maps that answer this question for me um, as well. So I only have to calculate it one time if somebody calls this multiple times. Now, in theory, you'd only call it one time. You'd build it and call it. You'd have that data, but it's always good to think about in terms of efficiency. Um, so um, this is going to return um, best cost per win map, and it's going to return worst cost per win map. Oh, I'm sorry, that's all time. Um, Sorry, this is individual team. So wait, so let me go back to my outline, make sure I did that right. I apologize. Like you. I'm trying to figure out what the heck the author was asking me for. Back to my outline. Yes, so I have maps for those. Do I have individual ones? Darn it, I can't see. Oh, best attendance I have, but I don't have the individual ones there. Okay, so that's fine. I probably could and should, but let's. All right. Yep. So we'll come back to that in a second. So this one is the one I was doing. Um, Sorry, I have my caps locked on. Best cost per win, and this is going to be the worst cost per win. That's where I meant to do this. All right. Um, so either of these could return that value, but I have to fill that value. So if best cost per win is equal to null, then I'm gonna create a helper that says build costs, and then I'm gonna do the same thing down here. Change this to be worst. So whichever one of those gets called first, I'm gonna go build the costs for both of them because I'm gonna have to loop through all my data anyway. So I might as well figure out both sides of the coin as it goes. Now, this very much relates back to what I was doing up here. So I could, in theory, you know, build all this data at once at any point I want to. I'm just kind of showing you some different strategies that you'll be able to pick up on later on. But I'm going to create a private method here that's going to do the work that I had up above. Um, Oops, and this should be null for the moment, and this should be null for the moment. Um, All right, so we'll come back to those in a second. So let me come to this data right here. I know I'm going to do something similar to this, um, and so let me just copy this first couple lines of code when I talk about building the data, building the cost right here. So for every team, I want to go through and figure out in all teams, all years, who has at each different win total, because that's what we're talking about here, the best cost to win total of all time, and then I can also track who's the best of all time in that as well. All right. So we don't have a given year that we're going to go through here. So we're actually let's go through the loop twice. And this is going to be all teams dot values. So for every year, for every team, we're going to go through every team that's out there, and we're going to calculate this ratio that I had up here. And so that ratio is cost per win, right? All right. And so what I want to track is, okay, if a team won one game in a year and they spent $1 million in salary, that one game cost them $1 million to win. If they won two games, it cost them $500,000. If they won three games, it cost them a third of $1 million. If they won 100 games, it cost them $10,000 a game to win. So that's the statistic I'm looking for. So how much cost in salary did it have per each win they got? And I want to track that per the number of wins they got. So I want to build the best cost per win and the worst cost per win. And this is going to be a tree map. That's going to work for me because it's going to order them. It'll be easier to print them out. I can see low to high or high to low, or low to high. I think is what we're going to do. And then worst cost per win here. Okay, so I'm going to build both of these at the same time because I'm going to go through every single team and calculate the cost per win, and then I can actually track the I'll come back to that in a second. I need to answer that question. I don't remember how I did the other one. I'm not going to overload myself or you with more things to think about. So what I do want to think about here, though, is the entries into this cost per win variable. So right now, the best team is going to be is equal to going to be that tree map, best cost per win dot get for the number of wins that the current team I'm looking at has. So team dot get wins. And so if best is null, so we don't have a best yet, or the cost per win is greater than the best. Oops, I'm sorry. This is team info. Let's be more accurate there. Best dot get team salary divided by best dot get wins. So if either there's not one there, or let me get rid of the outline. Either there's not one there, or we exceed the one that's there, then we're going to say best cost per win dot put the team dot get wins and the team. So if we're better than the team that's out there, we're going to replace it, or if there isn't a team yet, we're going to replace it. Otherwise, we go on to the next team. Now, we're not going to go on the next team quite yet, because then we're also going to do the same thing right here for worst. So we're going to change this to be worst. I'm going to change this to be worst, and we're going to change this to be worst, and this is going to change this to be worst, and then we're going to change this to be worst, and then we're going to change this to be worst. All right, and so you can see how we can do both at the same time. That's why I had this little helper method here. Now, you might not have thought to build a little helper method right away. That's okay. You'll learn to do that in time. In my brain, I'm like, oh, these are the same structure. I'm going to copy and paste this anyway. I'm just going to build them both at the same time. You could always build one of them, recognize you're building the same thing, and create a helper method. Or not do a helper method and do the work twice, which is inefficient code, but it works. You can always make it more efficient later on. So I don't know if this is going to work or not, but let's see. It seems like it should work. It seems pretty straightforward. I might be lucky. So let's see. Test best. It's saying best of all time is not correct. Expected 1998. Oh, it's because I haven't done the overall best of all time. so I missed that one. So the first thing it says the best of all time, and then it looks at a couple different individual years. So I do need to solve that one before I get that done. And again, I'm not sure why I don't have a best overall. I have best attendance, but I don't have the best overall. So I'm going to actually um, change just to be best cost and worst cost. I'm going to add these in here. Again, I don't know why I don't have that already. Maybe just to give myself a wrinkle, but best cost, or maybe I built it a different way. I don't know. Best cost and worst cost. Oh yeah, and I can actually probably add in the same um, logic here to go off and build it, since that's being built first. And it doesn't matter if it's best or worst. It actually, any one of them is a signal that it's been built. Um, so one more check I need to do right inside of here. So I need to say if best cost is equal to null, or same thing here. I'm just copy this. And now this is best cost. So this is the best overall right there. Then if I'm better than the best overall, then I switch that team out. Makes sense? And do the same thing for worst. Change the worst, change the worst, change the worst. So this is the number one all-time team that spent the wisest and that spent the most foolish, perhaps, in garnering wins. So let's see if this gets me to where I want to do. All right, so best all time is not correct. It is saying it should be the 1987 Texas Rangers, and I returned the New York Yankees, the 2013 New York Yankees. I did it backwards again. Why? Because for me, bigger is better. And we forget, in this case, our statistics, lesser is better. So we need to flip our signs on all of these. Oh, I'm sorry. The worst might have actually been correct. Let's see. So the best cost per win should be if the cost per win is less than, and the worst cost per win is the cost per win is greater than. So maybe, I don't know. Let's see. Let's see where we're at. Texas Rangers. Texas Rangers. 2017 Texas Rangers. Oh, now we're into the team salary being 0. And I'm not sure what happened there. So let me tell you what. I'm going to go look at that real quick and see maybe if for some reason I have a bad data set that I uploaded. And if that's the case, then I will let you know right away at the start of the next video. But it'll be corrected already, actually, because you won't have seen this yet. But yours might be working, and it might not. But let me go check out what's going on.